Welcome to the class Artificial Neural Networks. This is part 2 of the first lecture on deep networks. In this part we consider the XOR problem. The XOR is a famous example. The XOR problem is defined in 2 dimensions. I have 2 positive examples. They lie at positions 1, 0 and 0, 1. And I have 2 negative examples. They lie at positions 0, 0 and 1, 1. The name XOR comes from the corresponding logical operations. XOR for exclusive OR. Now, most databases have many more points than just 4, but the configuration of an XOR-like problem is quite common. So I could have 2 clouds of data points lying here and there, 2 further clouds of data points lying at the opposite corners. And so we have many data points, but the structure of the problem is exactly that of an XOR problem. So how can we use a neural network to solve the XOR problem? Solving meaning that all the positive examples give an output 1, all the negative examples give an output 0. Well, let's take a first neuron. And I have 2 inputs and then this extra input for the threshold or the bias. Well, this neuron cannot solve the problem. What this neuron can do is to construct a hyperplane with some weight vector, and the weight vector would correspond to the set of weights that characterize the input to this neuron. So this is one neuron. Now let's add a second neuron which has a second output, and the notation is that this is the output in the first layer, in the first hidden layer, because it's not yet the output layer, and this is neuron 2, whereas this is neuron 1. So neuron 2 can also implement the hyperplane, and we choose for neuron 2 the hyperplane here. Now let's consider these 2 neurons as inputs to a further neuron. So this is the axis of the activity of this neuron, the activity of neuron 1 in layer 1, and the other axis is that of neuron 2 in layer 1. Now all the data points that in the input space are positive examples lie on the correct side of the red and on the correct side of the blue neuron, so they all lie here at 1, 1. Similarly, data points that are negative examples, well, they are correctly classified by the blue neuron, but not correctly classified by the red neuron. This is correctly classified by the red neuron, but not correctly classified by the blue neuron. So this group goes here, and the other group goes here. And now I can take a further neuron and classify. And this is then my output neuron. And so this neuron is now the neuron in the second layer of a single neuron. I don't need a further index. And this neuron defines the output of the network. And all positive examples will give a 1. And all negative examples will give a 0, which means this 2-layer network solves the XOR problem. In conclusion, a 2-layer network can solve the XOR problem. In fact, a 2-layer network can solve all sorts of non-linearly separable problems. In this part, we constructed a solution. However, the aim of neural networks, of machine learning, is to have automatic methods to find the solutions. And this is the topic of the next part.